want to do that experiment? You do want to do it. So let's do it at a separate time other than this. And let's concentrate on chapter 2, acids, bases, and buffers. Okay? Now the first thing I want to mention that we start off with just calculating the pH. Hopefully you all remember how to calculate your pH of a strong acid and base. So the one that grabs most people is the calculation of a weak acid or base. And in Gen Chem what we had was the equation that Ka, the equilibrium constant, is equal to A minus over H plus divided by HA, and we assume that these guys are X, and that guy is technically minus X, but it's close enough to HA. So you do that calculation first, say that X is H plus, and then you take minus the log of that to get pH. Now if you read the textbook, you see that the textbook on page 39, on page 40 for bases, and on page 48 that has a summary of equations, uses an entirely different equation. The equation they use to calculate the pH of a weak base is pH is equal to pKa minus the log of HA concentration, which would be the same as that HA concentration divided by 2. If you work at it a little bit, you can actually derive that equation from that equation. So they give you the same answer. This one gives it to you in one shot. And so a lot of people like to just use that one. It's a black box. I prefer that equation because that goes back to the Gen Chem that I taught you. But if you want to use that one, go ahead and use it. Doesn't matter to me. So I thought I'd get that one out of the way. So at this point, you can calculate pH of weak acid, strong acid, weak base, maybe, strong base, hopefully. Then we'll just go straight on to the buffer. And what we've had in class is the buffer equation, good old Anderson-Hasselbalch. pH is equal to pKa plus log of A minus over HA. And I just thought I'd set up an example. This is not any of the calculations that you do for the lab, but this is an example that takes you through it. And say I wanted to make 500 mils, 0.1 molar pH 8 buffer. When you're using Anderson-Hasselbalch for this ratio, you can use either moles or molarity. So the first thing I'm going to do is calculate the moles of total acid. And we've got 0.5 liters times 0.1 molar, 0.5 times 0.1, 0.05 moles total. And that would be tied up in both HA and A minus. And then as we've done in class, we'd say, okay, this is the pH I want. pH is equal to pKa 8.3 plus log of that guy over that guy. We'd say that the sum of those two is 0.05. You've got two equations and two unknowns. Solve it, and once you solve it, you could weigh out the amounts of those two, put them in a beaker, and make your solution. But the big emphasis here is real chemists don't bother. I don't think they like doing those calculations. That's something for analytical chemists. And the answer you get, generally your pH isn't going to be quite right anyway, because there's some other things like caca in the beaker, or a little round off error on your calculation, or just some effects in the solvent that don't give you exactly the right pH. So if you're making up a buffer, you don't do that. Instead, we'll start off with the same place. We've got 0.5 liters times 0.1 molar. We know we want 0.05 moles. And then you just say, well, let's see, I've got a couple different forms of tris up here. Let's see. One is this tris that has a molar mass of 157.6. Another is this tris that has a molar mass of 121.1. And just because I grabbed that one last, that's the one I'll start with. I'll say 121.14 times 0.05 moles. So I'm actually going to be starting off with the base form. I don't care about A minus or HA. I'm just going to start off with one form, and I calculate the number of grams of that. I weigh it out. I put it in a beaker, and I dissolve it in about 400 mils. I want a final volume of 500, so I'm going to dissolve it in 400. And after it's all dissolved, then I put my pH probe in there, and I measure the pH. And I see whatever it is. If it was the base form, pH is going to be high. was the acid form, the pH is low, and then I just grab the appropriate acid or base from the lab bench, add it to it until the pH is at 8, and I let it stir a little bit. I add another 100 mils or so to bring it up to 500 mils. Check the pH one more time. pH is good, I'm done. If the pH is off, I can add a drop or two of acid or base, and I'm done. I didn't have to do any A minus over HA, and I got the pH that I wanted. The other thing on buffers is you almost never worry about getting out your volumetric glass flow. Buffers just hold the pH, and it doesn't matter if you actually made up 502 mils instead of exactly 500. So you won't even measure, pull out the, drag out the 500 mil volumetric. You'd probably just look at the side of the beaker and say, that's up to the 500 line. Good enough for a buffer. So it's a lot sloppier, but a lot faster. And that's the procedure they outline in your textbook. They say, just find out your total, weigh it out, dissolve it in like 3/4 of the material, adjust the pH, add a little more water, and you're done. That's all there is to it. So that's what you're going to be practicing for today's lab. You'll be doing part A. And in part A, you're going to be assigned 2 buffers. The assignment sheet is right there. So for each group, I've assigned 1 buffer, which is either phosphate or citrate, and a second buffer that says other. So with the phosphate or citrate, you find either phosphate or citrate material over there, you bring it up to that given pH, and you make a buffer. For the one that says other, that means you can use any salt or any acid or base that's out there, whatever you want. And this is the one that you have to think a little bit about. Because remember how we said that the buffer's best when you're right at the pKa? So if I have an assigned, so you look at your assigned pH and you say, okay, my assigned pH might be 3. You now look through the list of buffers and find the buffer that has a pKa as close to 3 as you can. And that's how you choose what you're going to use for the other material. And then you go through the same material, you weigh it out, you bring the pH up, and do it all. So, just told you how to choose the salt, closest to pH. There are lots of salts up there. Second thing to pay attention to is your book had a limited number of different salts. I did this as if you actually went to our stockroom, and I grabbed out every citrate salt that I could find, every phosphate salt that I could find. And so you're going to have lots of other molecular weights, depending upon which salt you grab. And so when you do this, don't rely on the molar mass that you just calculated for your pre-lab question. Go up, actually look at the bottle, and look, find somewhere in the bottle where it says what the molar mass of the material in this bottle is, and use that molar mass, not something that came out of your textbook. There's one here that I got to think a little bit about. I know it's a phosphate, but somebody tore the label, so I'm not sure exactly which phosphate salt it is, but it does have a molar mass on there, so you can use it for a phosphate buffer. Okay, so that is part A. Lots of salts, not the same as the book. Use the molar mass on the bottom. Now, how am I going to check you on this? The way I'm going to check you on these 2 buffers is I've assigned you things, and when you're all through the buffer, over in the hood over there is a bunch of little slips and a bunch of little vials. I want you to fill up 1 vial for each of your buffers. And then tape on that vial that little tag that says what group you are, what the assigned buffer was, what the pH was, and how much mass you actually weighed out. So I can double check all of your calculations, and I'm going to check the pH for myself and see if it was at the assigned pH. And I think last year was, if you're off by plus or minus 0.1, no points off, but for every pH, 10th of pH you were off, that was a minus a 10th of a point, or something like that. So that's what I'm going to be checking. How close you were to pH, and did you choose the proper buffer for that other one? And did you calculate the proper weight that you should? Now, once you've got in the vial, don't throw the rest of it out, because you need the rest of it for both part B and part D. So you can fill up the vial now, but save the bulk of it because you need part B and part D. Other thing I should say, I don't know if we've got enough caps back there for all of the vials. It looks like we're short. So if you can't find a cap for the vial you're using, just grab a piece of parafilm and parafilm on top. Okay, part C. I've made up 3 different buffers that you have to check the pH. They are sitting in the hood over there, just labeled 1, 2, or 3. Choose any 2, measure their pH, put it down on your sheet, and that's all you need. Part D, the book says add 0.5 mils, or you're doing a little mini titration. Rather than trying to measure out exactly 0.5 mils, just use 10 drops at a time. See what's going on. So the bulk of the materials coming from this manual, so use that one for the write-up. But there are a couple of important things in the yellow manual. The first one is for experiment 1, you are responsible up here for the pre-lab questions for 1, even if you're not doing it as an experiment. And you will be responsible for the additional problems 1, 3, 6, 9, and 12. So put it up there. It's also in here as far as reciting. And the rest of it is pretty much what I've said on the board. The second thing you need to know is how to calibrate your pH probe. Because back in Gen Chem, I ran through the lab very quickly and calibrated everybody's pH probe. You guys are big boys and girls now. You've got to do it for yourself. So that's on page 6. So go ahead and calibrate the pH probes for yourself. And that is going to be part of, can you hit this pH right? Because you have to have pH probe calibrated properly before you can do anything. Now, one thing it mentions in here that I'll emphasize, when you calibrate the pH probe, you should choose 2 pHs to calibrate it. And the way the bench is set up is on each side of the bench, I have a set of 3 different calibration buffers, 4, 7, and 10. One here, one there. And with those, you grab the 2 pH standards that are as close to the pH you're trying to measure as possible. So if you're trying to make a buffer at pH 3, you grab 4 and 7. Try to make a buffer at pH 11, you grab 7 and 10. And that does require, if I gave you one buffer at pH 7, or one buffer at pH 3 to make, and another buffer at pH 10 to calibrate, you have to change, you have to redo the calibration between runs. And when you get to your unknowns over there, if your pH probe was calibrated between 7 and 10, but you grab an unknown over there, that's a pH 3, you should recalibrate it before you measure that pH 3. So you always have to calibrate it as close to the proper pH as you can. When you're making your buffer itself, you'll put in your acid or your base, and then you have to adjust the pH. For that, I've got 2 bottles of 1 molar NaOH and HCl at each major bench. So I don't have one for each side like I do the calibration solutions, but I have 1 pair at each bench. If you need more of these little pipettes, I can grab them for you. You are all given a stir plate to start with a magnetic stir. Leave the stir on top of the stir plate when you've done today, so I've got them all accounted for tomorrow for Thursday's lab. I think that covers about everything. Go ahead and get your goggles on and get started. Just had to do it, didn't you? Real mature. Yeah.
Hey, Rebecca, we're 6.
pH 6
Or
and
citrate 3.0 and other solution.
what?
Right? Citrate buffer and another.
And then a pH 6 and 10. Where's the sensor tab at? I don't know.
Technology.
Got it.
And I forgot my
Okay,
yellow.
touch the sensor tab, touch the calibrate button. So do we... below our target pH, so we're gonna have to recalibrate it multiple times.
Or
Because our target pH is 6 on one of them.
6 and 10.
Yeah. We're gonna have to go between 4 and 7 for one and 7 and 10 for the other.
Yeah. So we have that, okay. Where's the calibrate button? Oh.
But do we need to
We need to get a
change it? Yeah, but do we need to put it in a different buffer?
You want that?
So do we, oh wow.
So one of those.
So do we push calibrate now when it's in this solution and then change it to the buffers that we need to change it to?
I'd have your
Or-
buffer right.
So do we just take this and put our sensor in it?
Okay, so you remember the proper technique from Gen